Okay, college algebra students, what we're going to do is look at our last chapter, our last section of chapter 2. Again, it's going to create some other equations that we can, graph from, fit, in this case, a lot of word problems actually. So what we're talking about are variations, and there actually are two types. Oops, let me bring this down. There's either direct variations or what we call inverse variations. So let's kind of talk a little bit about what each one is, what they represent, and then we'll start getting a little bit more mathematical in orientation. So basically, right, what does it mean for two items to vary directly with each other? Okay, and of all the items, this is probably the big one. So two items vary directly with each other. What that basically means is that if I have one item, if it goes up, then let's call that item 1. Then item 2 will also go up. Maybe not as fast, maybe faster, right? But directly, right, they do the same thing. If item 1 goes up, item 2 goes up. Vice versa, if item 2 was to go down, right, then item 2 would also tend to go downwards. And again, whether it's equivalent or by more or by less depends on another factor. But that's basically what it means to be in direct relationship. I have two items. Let's call them X and Y if you want, right? That when X goes up, so will Y, right? If Y goes down, so will X. So it's a two-way street here. So basically, something goes up, the other goes up with it. Something goes down, the other goes down with it. That is basically what a direct variation is all about, right? So let's stop and think, right? Can you think of any day-to-day relationships that could be described as a direct variation? And it turns out that there are a lot, all right? And probably the most famous one, I'll give you one example, and then you guys can probably take it there, is basically your pay, particularly if you work hourly, all right, your hourly pay. So let me go ahead and let P be the amount you're getting paid, and let's let H be the number of hours that you work, right? So P is the dollars of pay, and H is the hours worked. Okay, and P, right, the amount I get paid is basically some number, right, your hourly wage. So let's just say it's 12 bucks, right? So the amount I get paid is 12 times H. And this is a classic situation of a direct relationship. You can see that if my hours go up, right, if I work more hours, what's going to happen to the pay? It's going to go up, right? So if I work 1 hour, I get a pay of 12. If I work 2 hours, right, I'll get a pay of 24. Of course, that's without taxes, right? Taxes are another story. But that is basically a direct proportion, right, or what we call a direct variation. I mentioned taxes, right? We know, right, the amount of taxes that we pay are usually a percent, let me call that tax, right, of, let's say, our income, or might be our pay, right? So what I have there. So T, right, let's, I don't know what the going rate is. Maybe it's 0.062 or something like that, all right, of my total pay, all right? And so again, you'll notice what's happening is as my pay goes up, right, as my income goes up, so does the amount of my tax dollars, right? I think come tax time, right, maybe somebody's paying 25% of their total income. So again, lots of different, if my income goes up, if I earn more, I'm taxed more. If I earn less, I'm taxed less. So that idea of as one goes up, the other goes up. As one goes down, the other goes down. So classic direct variation. And what you'll notice is you can tell a direct variation from the next one I'll show you because it usually involves a multiplication. So let me come back to up here. Usually what we have is Y, right, being an output, is some K value times our X. And in this way, we say that Y is directly varying with X. And that's the language we use that. So it involves a multiplication. So there's some constant multiplied by X that will give me my Y. So here that constant was 12, right, my hourly rate. Here this was, I think that's actually your FICA, your Social Security is 6.2%, right? And then here might be our income taxes when I have to pay on April 15th. I'm going to pay 25% of my income. So the K would be 0.25 and here it would be 0.0662, all right? And so basically what we have then, right, is our examples of direct relationships, all right? So the next one, right, that's direct. The next one is called an inverse, right? We're going to vary inversely. So if you're kind of thinking about what we said here, again, let's talk about x and y here, right? This means that as x goes up, what's going to be happening to the y? It's going to be going down, right? They're inverses of each other. They're not doing the same thing. And if x would go down, this actually means y would go up. All right, so they're doing kind of, it's not an opposite, right? They're just doing, their motion is in another direction. I'm trying to not use the word opposite, because opposite means there's negatives around, and we can have no negatives around here to do this. Okay, so this one is a much harder one to fit, right, to an everyday relationship. But I think the closest thing that I can get to it is think about when you're holding a couple of magnets. Right? I don't know if you guys have ever done this, but when you're holding a couple of magnets and as you bring them closer together, right, you can almost feel that little force about them as opposed to if you put them further apart, right, the force goes down. So basically what's happening here is the distance decreases, right, the force increases, right, and there's that idea of they're going in different directions. So as distance gets smaller, the force gets bigger. If the distance would get increasing, then the force between them would actually decrease itself. And I actually think heavenly bodies to do this the way as well. Like there's a force between the Earth and the Moon, right? And basically that force depends on the distance. If the Moon was to move further away, then the force would go down. If the Moon would come closer, then the force would go up. And it's pretty much why satellites end up crashing, right? If they stay within orbit, they're staying within a good balanced distance, but move that distance up or down, the force starts moving up or down, and if it's in the wrong direction, right, the gravity starts pulling that satellite back, right? So what happens here, let me just cut to the chase, is we end up with y equals, this time our constant, rather than being multiplied to x, is actually being divided by x. And here y varies inversely with x. So you can get a feel, again, this is a constant number, so 1 or 2 or 5, right? And if x gets big, taking a number and dividing it by a big number would make it really small, right? If x is already small, like it's very, very tiny, taking a number and dividing it by a tiny number makes it very big. So there, right, is our inverse relationship. Both of them involve a k, right? There's we'll give it a name here in a moment, all right? And but in a direct relation, that k is being multiplied to the variable, and in an inverse, that k is being divided by a variable. So with that in mind, all right, what we have, let's go ahead down here, and here's some actual math equations. Let me try to kind of get it balanced here where we can see them both. There we go. Right? So direct or indirect, right? What are we dealing with here? What kind of variation? Well, again, you'll notice I'm multiplying a number 4 to the variable t. So this is a direct relationship. So as t goes up, d will go up. All right? As t goes down, d will go down. And the next one, right, notice that the 9, the number, right, is being divided by the variable. Well, that's a classic inverse relationship. So that's inverse. All right, and then the next one, we got to be a little careful here, right, because we're dividing, all right, oh, excuse me, I'm getting ahead of myself. Here again, there's the number, and we're dividing by the variable. So that again describes an inverse relationship. All right, and then letter D, like I said, I was getting ahead of myself. Let me pause here for a moment. All right, do you think letter D is a direct, or do you think it's an inverse variation? So let me give you a moment to kind of think. And if you said direct, you are right, right? Because keep in mind, I didn't say if there's a division it's inverse. You have to be dividing by the variable in order for it to be an inverse. Here we're not dividing by the variable, right? We're dividing by the number. And if you wanted, right, there's another way to write s over 24. You can write it as 1 over 24 times s. And so now the number is being multiplied to s, which is definitely what's going to be happening to a direct relationship. All right, and then last thought, we're already 10 minutes into this, sorry. This constant that I keep referring to, this k, this 4, this 9, this 10, this 1/24th, it has a name. It is called the constant of proportionality, that k. So in this case, k is equal to 4. It's the number being multiplied to t. Here, k is equal to 9. It's the number that's being divided by the variable. Here, k is equal to 10, because it's the number divided by the variable. And right here, k is equal to 1/24th, because that's the number that's being multiplied to our s. So there is our initial view of direct and inverse variations. Now that we have the equation forms, let's go do some more math.